Thanks for coming out tonight. One of my favorite things about this series of events and the way that this has been done is it's supposed to be fun. So I'm a huge fan of people drinking before my talks. So I hope you took thorough advantage. I'm not going to dance. I only dance when there's music. I will dance if forced to. Michelle knows that. But I'm not going to dance tonight because there's no music. And I'm going to try and get through this in like an hour-ish and make sure I leave at least 15 minutes or so for Q&A. So start thinking of your questions now. My background, so you know where I'm coming from, is really simple. It makes no sense whatsoever. I've done startup companies. I've worked in large enterprise businesses. I've been a customer of enterprise technology. I've been a vendor of databases and database systems. I've worked on the data side. I've worked on the application development side. And I'm an engineer by training, and I've also done a lot of business stuff. So I'm all over the map. The companies I work with, I tend to sort of orient around people who are really mission-driven and are trying to have a really big impact and change the world in some way that they care about. And some of those companies are up here. One of the ones that I'm particularly excited about in the database space, other than Tamr that we'll talk about, is SciDB. And so Dan Delaney is up here. SciDB is doing amazing work in informatics, bioinformatics, and cheminformatics. Really, really cool. A Ray native database system that is truly innovative. I've been working on SciDB, or what became Paradigm 4 now, for more than 6 or 7 years. And check it out. It's really cool. All right. So I'm like starting from the way up there, the 30,000 foot level. The enterprise is at a unique point in time. People that work in data in the enterprise have the opportunity to truly transform their organizations. We spent the last 40 years building systems to automate processes that create data in the enterprise. And now it's time to actually start using all that data that comes out of the accounting systems and the manufacturing systems and the supply chain systems and the CRM systems, and actually putting that data to good use. But in order to do that, the enterprise needs to start thinking of itself as the Googler of their enterprise. Their job is not to rack and stack servers or to create images on end users' laptops and make sure that the USBs work. And that's really not what enterprise IT folks are there for. They're there to help people in that company find information, access information more quickly, more efficiently, more effectively than they otherwise could. And so they really need to start thinking of themselves, in my mind, as the Googlers of these companies. Now, it's a hard thing to do. I mean, Google has some unfair advantages, some absolutely incredible people. But one of the primary problems we have in enterprise IT and enterprise data systems is that we're carrying around this drag coefficient, right? That we were all, a lot of us were around and kind of got into this profession when people didn't have their own computers, right? When they had dumb terminals and all this stuff. And somewhere over the last 20 or 30 years, enterprise IT took on the burden of making sure that everybody has a computer, right? It's really kind of crazy, though. How many people in this room have at least 2 devices, right? So what the hell is corporate IT people doing trying to make sure that they get another device or some special device into the hands of end users? Doesn't make any sense. People already have more computers than they know what to do with, right? But what they don't have is access to information. A lot of us go into a large enterprise, you go into work in the morning, and you have to suspend all the expectations that you have when you're at home about getting access to information and pretend like you're back in the 1980s. Or in some cases, the 1970s, right? And you have to go through VPNs, and you have to do all this crazy stuff, and you have to take the image on the laptop, and you can only use this browser, and that browser is like 4 years old. It's crazy. It's stupid. So we got to get out of this. One of the other big challenges that we have that I'm going to talk about in a minute are data silos. So this is kind of the setup for Tamr. What Tamr is, But over and over again, I've experienced this problem that organizations, when they start collecting data, they tend to be very idiosyncratic about it. That data gets collected in some database that's an application, and the data formats are specific to that application, or they're specific to a certain division within the company. And then when you want to do these very sort of broad analytics, again, access data the way that Google sort of has created this expectation for us to, you can't access it because it's locked up inside of some proprietary database somewhere. We'll talk about that more in a second. But in order for us to sort of break out of this, traditional enterprise IT and data management and analytics thing, we have to do some stuff differently. Now, this is my kind of wish list. If I took over as the CIO of Company X here in Boston, right, what I would be doing is trying to drive programs and drive initiatives that helped push the envelope on some of these things. Viz tools, amazing, right? D3, any D3 users out there? Right? Yeah, lots, right? Crazy popular. Processing, another great Viz framework, right? Ben Fry, who's right here in Boston, and good friends of mine and Thomson Reuters. Amazing stuff. Spotfire, right? One of the coolest Viz packages out there. Started right here in Cambridge. Very cool system. And then, we have to take advantage of the fact that, like, we're all here. I joke around every time I get these calls. I live in Harvard Square now, and I go over across to HBS, give talks once in a while. And when we were starting Vertica back in 2004, like literally 10 years ago, like almost to the day, one of our investors asked me to come over to HBS and give a talk on database systems, right? In what essentially was big data. How many people showed up? Like, they blasted it out to the whole thing. 5 people showed up, right? I just went back a month ago, right? They did the same thing. We had 300 people show up. Now, these MBAs, we all know, right? I'm one, I disavow it, but they're like lemmings, right? Like, they follow stuff, right? So the time is right, though, for us right now to take advantage of this enthusiasm and the interest and use that to do some re-architecture. Bring in some of these cool new tools, do some interesting things, and maybe cut through some of those political bottlenecks that we've had before in order to really re-engineer for agility and to do things faster. Again, I'm going to talk a little bit in a minute. These data warehouses, like Vertica, we went around the world building large-scale data warehouses for the biggest companies on the planet. Facebook is one of our big claims to fame. Many, 10-plus petabyte data warehouse at Facebook. And, the only way you get to the scale that a lot of these big data systems require is by abandoning some of these old tools. We used to say at Vertica all the time that, using Oracle to do data warehousing is like, trying to go out and win NASCAR using a 1975 Ford Granada. Right? Like, literally, like the design specs for the Oracle engine were written in the late 70s and early 80s. Right? We can do better than that. All you have to do is take these existing systems, kind of put them aside, and say, well, it's good for something, traditional business transaction data processing, but it's not good for everything, especially for data warehousing. Data is not perfect. Entities that we define are not perfect. Static schemas are a bad thing, right? So a lot of data people here, so I can talk about schemas and not get, some kind of revelation. But static schemas are a really, really bad thing. Oftentimes, data projects in the enterprise start with someone saying, well, assuming that this schema doesn't change, or assuming that these are the only attributes you're ever going to use. And it's just not true. Right? The dynamic that we've got in enterprise data is that it's much faster than that. It's much more aggressive. It's changing too quickly. Give up the static schemas. Data variety is a reality. There's lots and lots of data around. And again, we've got to break out of this sort of application-specific data systems. Semantic approaches are really good. All this semantic web stuff, I did a bunch of this stuff in the last 15 or so years that Tim Berners-Lee has advocated for. Like, these semantic systems are really good. Triple stores are not something to be afraid of. They're actually really powerful, but they are just one thing. And that we really have to get into this idea of building systems on command that are more agile, these like dynamic data marts, we call them. All right, so if you're going to do lots of this stuff, right, you need the classic 3 V's, right? Volume, right, for me, that was expressed with this company Vertica that we built. Velocity, another company that we actually spun out of Vertica called Volt, who's a sponsor tonight, that is doing great on velocity and helping with velocity. And again, Tamr for us is really about addressing variety. And so my partner, Mike Stonebraker, and I have spent a lot of time worrying about the 3 V's, worrying about whether the world has large-scale distributed systems to enable people to address all 3 of these V's, and then going out and building real systems in order to do that. So, but before we get into the tech, right, like one of the things that is ultimately important is that you have to start with the questions. My friends who shall remember these folks at Novartis, we went through this process at one point before we actually did our big data work to say what are the questions that really matter analytically, the aspirational questions that really make a difference. And so we spent a long time actually cataloging what those questions were. And these questions then can be decomposed into queries. And even if you don't have the data that's necessary to answer those queries right then, at least you know and have a framework for what they are, so that as you then start to implement technologies, you can use those questions as a guidepost to determine what data systems you need to build, how those data systems need to perform. You have a set of analytical context that you're going to use to make all of your key technology decisions. And if you don't have that, you kind of run the risk of getting caught up in, one of my favorite things is Hadoop, the H word, right? And so I'll get it out of my system. I tend to do this. Hadoop, right? All right, I'm not going to say it again, right? I've filled my quota, right? But it's not that big of a thing, right? For anybody that's been around in database systems for years, the key principles that underlie HDFS, it's another file system, it's a distributed file system, it's great, but it's just another file system. At the end of the day, everything in data systems gets down to how you put bits on disk and how you get those bits off. And those decisions that you make by the technologies that you choose are going to influence whether or not you can put bits onto disk really fast enough, whatever that means for you, or whether you can get them off fast enough. Okay? All right, so as you go through this process of looking at new tech, I think there are a bunch of things that are really important. One here is expecting to use the cloud. So using AWS, using the cloud to scale out, starting with distributed systems as a fundamental principle is incredibly powerful. It lets you do things very, very fast. Michelle and I, experienced this at Novartis, right? The average time to provision a new box inside the data center is somewhere between 3 and 6 months, right? It's crazy. And most enterprises are like that. It's nuts. So using the cloud gives you this tool to be more agile. DevOps, if you're going to use the cloud and you're going to do these distributed systems, you have to get really good at DevOps really fast. I think JSON, so how many people here are fans of JSON, have used JSON in the form of Mongo or Couch or something, right? Like JSON is becoming, for database systems over the next 10 or 20 years, what SQL was over the last 20 or 30 years, right? JSON is going to become the lingua franca, right, for applications and how applications get at data and how people get at data ultimately. So now when you start off in looking at these questions and start asking these complex analytical questions, the answers aren't always really simple, and even the questions themselves depend on context. And so part of the reason you have to have this ultimate flexibility in your infrastructure is when you're asking questions, you may mean different things when you use the same attributes. And so you want to have analytical context, and you want to be able to change and morph analytical context. This is just an example. This is all the different sort of ways, or you can represent a major drug. Novartis, the big drug is Cloudant for cancer. So you can have an INCHI key that's a simple binary representation of this compound. You have a two-dimensional structure, a three-dimensional structure. You can have many names for the same drugs out in the market. what do you mean when you say Gleevec? And when you ask, run a query against Gleevec, what do you mean? Which one of these things is what you're actually asking? So having done a whole bunch of these projects over the last 10 or 15 years, and you really have to start with a greenfield. Huge problem in legacy systems and legacy infrastructure is that you have this tremendous legacy overhead. And so oftentimes you're better off like starting from scratch. Start with a new project where you can start from scratch and do your own thing, demonstrate these new principles, and then over time expand that, and don't boil the ocean when you first start. Again, great visualization really, really matters. So D3 is really popular. Processing. If you haven't had a chance, if you're really interested in Viz and you haven't had a chance to check out Ben Fry, or he's got a small consultancy here in Boston called Fathom. I mean, it's truly a unique advantage for us here in Boston to have Ben. I mean, he's world class. He's one of the best in the world. And so if you're looking to do state-of-the-art visualization stuff, please don't hesitate to call Ben. If you can get any of his time, it's really transformational. Every project I've ever worked on with him has been wildly successful. Distributed systems. So here's another sort of big pain point for me. Part of this legacy cost that we have is that Oracle and EMC have spent a good chunk of the last 30 years trying to get as much of the enterprise IT budget as they possibly can, without regard for whether or not the systems that they're selling you, the software that they're selling you works. Right? So let's just let that sink in and think about the billions of dollars that are spent on Oracle and EMC. And at the end of the day, well, that would be nice if it worked, but it doesn't really have to work. And again, you look at what they did. One of my favorite stories about this was from our Vertica days. And when you think about what they did in data warehousing, there was a movement in the early 90s to do what we now call sort of modern data warehouses. And Oracle kind of got wind of this. Larry Ellison gets wind of it. And then what they devised was what became materialized views. How many people here use materialized views in Oracle? Anybody? All right. Oh, that's good, actually. That's reassuring. But they invented this as essentially cache to put on the front of Oracle so that none of these other database vendors that were doing sort of better data warehousing systems could actually get traction and work incredibly well. Delayed for like 10 years the opportunity that became companies like Netezza and Vertica and these other things. But there's these big vendors have a vested interest in you continuing to use their crappy old technology, right? And so if you want to get out of that dysfunctional cycle, right, you're going to have to break the mold, right? You're going to have to decide where you're going to allow them to take money from you and where you're not, where you're going to stop. And the infrastructure that you're ultimately going to need for these kinds of things are much more like the infrastructure that you see at Facebook and Google and all these places, right? OpenStack is fantastic, right? It's exactly what you want. The cloud's a reality. So this is, it's amazingly powerful. A lot of times you get these complaints about, cloud infrastructure. It's like, oh, well, you can't really scale, or I run my own data center, I can control it better. Well, Netflix is pretty amazing, right? They run this huge service. They run the whole thing on AWS. They scale out incredibly well. And not taking advantage of the largest computing resource on the planet that's available to you on demand seems like a very, very naive kind of a thing, right? It's back to this thing. We're not in the 70s or 80s anymore. We don't have to deliver computers to people's laptops, right, to people's lap, or servers for them to work on. These things are available on demand as much or as little as you want. And then, people say, oh, what about security? So we get into the security thing. Guess what? Biggest security risk in any organization are the internal IT employees that can walk up with a USB stick, put a USB into a machine, and walk away with whatever they want. How many disgruntled IT people are there in the world? I know I'm one, right? So you don't want to do that. Actually, controlling access by using the cloud is a really powerful tool to enable security. DevOps is one of the coolest things out there. I don't know, how many of you sort of have been a part of organizations that have practiced modern DevOps, but using tools like, all the Atlassian tools and New Relic and all these great things. AWS reInvent is, I think it's next week or the week after. And if you get a chance to go to reInvent, you absolutely have to do that. I really highly recommend. It's amazing when you see the scale of what's going on and how people are leveraging modern DevOps to consume lots and lots of systems very, very quickly and elastically, and then give them back in real time, and optimizing the costs and using spot instances. It's really remarkable, what's going on. Embrace modern DevOps is a key message from me. JSON, as I mentioned before, is really important. Mongo is everywhere now, right? And this is amazing, right? Mongo's not my favorite thing. I'm more of a fan of Couch, and we built this system called Cloudant that we know, the company we sold to IBM. But the real power for me of Mongo is not in their underlying architecture, which again I have issues with, but is rather in the popularity that they've driven for JSON. JSON is an incredibly powerful and ubiquitous standard, and is going to be the lingua franca. And so I'll never forget one of my favorite moments at Cloudant. We were sitting in a board meeting, and we were talking about kind of the next set of technology developments we were going to have to go through. And one of the things that came up and caught my attention was our CTO, Adam Kaklowski, who now runs all of information management for IBM, as the CTO for information management at IBM. Adam says, well, we've been talking to the Mongo guys. And I'm like, whoa, wait a minute, right? What's going on with that? These are supposed to be your mortal enemies. He's like, yeah, we've been talking about, how people do access, and we've been talking about maybe doing a declarative language on top of Mongo and Couch. And we want it to be consistent. So what are you guys' thoughts in terms of a declarative language that we should use? And I was like, whoa, right? Because what's the logical answer? Anybody? Come on, you guys wait. The beer's settling in now, right? No, SQL, right? You want a declarative language to put on top of a database that makes it easy for people to write programs against? It's SQL, and everybody already knows it already. So here you had the hardest core NoSQL guys in the entire world, right? Billions of dollars sort of market cap at stake, hundreds of millions of dollars of venture capital invested in these companies that were NoSQL companies, and they're like, we need a declarative language, boy. And they're like, oh yeah, SQL actually is probably the best alternative, right? But what do? Once you're this NoSQL guys, you can't say, oh my gosh, well, you should really use SQL, or we're going to build SQL. So, again, back to these key principles, there are only so many ways to get bits onto disk and off of disk, right? And sooner or later, you come back to these same design patterns, especially when you get into very, very large scale. And so SQL is pretty good. And I think you'll find that the declarative languages that these guys use in complement to JSON are very similar to SQL, if not exactly it. All right. So now I'm going to talk a little bit about Tamr. So I'm going to try really hard to not make this a commercial, but I'm really excited about it. And when Mike and I started Tamr, it started off as Data Tamr, but it's so popular now to use data at the beginning of your company name that we said, well, let's just drop the data, and then we'll drop the E, which is kind of what all Silicon Valley companies do, right? Just drop the vowel. And we said, well, all right, let's put that. Well, we incubated Tamr for 2 years at MIT, and then we started the company about 2 years ago, so it's been about 4 years total invested in this. And the real goal of Tamr is to really help companies manage the variety of data that exists. And when I say data, I'm really talking about tabular data. Right? Could be something as lowest common denominator for us is a spreadsheet or a CSV. And a lot of the ways that people have dealt with this variety in the past is to try and standardize all their data systems. Well, if they all just use the same schema and stuff, we're going to be able to move data back and forth. It's going to be easy. Or they say, oh, if we can just get it into one place, then we can kind of massage it and get it right. And we think that in the enterprise today, that trying to standardize your way or aggregate your way out of this data variety problem is akin to trying to standardize the way that people write websites on the modern web. It's impossible. What does Google do? Well, they just crawl all these websites. They learn what they can. They use advanced machine learning in order to figure out which terms people are searching for and make sure those pop up on the first page, the best links pop up on the first page. And it's kind of the same for enterprise data. This is what Tamr's trying to do, is really trying to bring to enterprise tabular data the same techniques that are used to make data generally available on the World Wide Web. And we believe that it should be as easy to add a new data source inside of the enterprise as it is when a modern website comes live, right? You don't even know that a new website has popped up. It just pops up, it gets crawled by Google, and then it becomes available if you search on that thing. We feel the same thing should be true for enterprise data. It should be that easy to find new data sources. But in order to do this, you have to have this bottom probabilistic approach to data curation, right, and integration. It's not about some 3-star wizard in a lab coat. Maybe many of us here kind of fit into that category, that say, this attribute maps to this other attribute. Well, like, how do you know, right? Well, I talked to the users, and the users said that these two things are the same. Well, which users did you talk to, right? That anytime you try and do this top-down or deterministic mapping of attributes or matching of records, you run into the problems of radical idiosyncrasy. You can't be objective enough. You have to drive this stuff bottom up. And then, after you've got these recommendations from the algorithms as to how these attributes might map or how the records might be matched, then you want to go through the process of actually engaging people and asking them whether the machine is right or not. And this is essentially what the Tamr system does. The other thing that happens when you realize that you can integrate hundreds or even thousands or many tens of thousands of data sources really, really quickly and easily is you start to think about external data sources that you could integrate into your analytics very, very quickly and easily. And so you start to look, you become information seeking in your behavior, and you start to say, well, geez, if it doesn't cost me anything to add a new data source, why don't I just go out and start looking for attributes that I can add to my catalog so that my analysts have as many resources available, as many attributes available as they can get, and have as many records on any given attribute as possible. And so what happens is you start to get information seeking, and I think that this is one of the areas where Thomson Reuters has been really very proactive and very innovative in viewing their role as providing this sort of additional or supplemental data into the analytics teams of some of the largest companies in the world that are their customers. And it's very cool when you start to see this. We actually had a really great meeting a couple weeks ago with Jeremy at Data Robot. And they've got a feature in Data Robot where you kind of can add a new attribute to your model, or you're going through and picks the best model. And it's a very natural integration point for Tamr, where Tamr can actually recommend attributes into Data Robot models that have the biggest impact on those models, and those maybe attributes that the users never even imagined were available to them, but are available in a third-party catalog. So it's pretty cool. I'm really excited about that. Hopefully Jeremy won't kill me for talking about it. So I'm going to wrap up so we can do some Q&A. But just, to kind of emphasize these key points for me, first and foremost, like your information, any company's information is an asset. This is even true as an individual, right? Each one of us, our information is an asset. Whether we've decided to share that asset for free or not in exchange for free email is a whole other thing. But every company has this information. That information is an asset. You want to start with a broad inventory of all your data. That we've got to get out of this model of sort of idiosyncratically building applications over and over and over again and replicating lots and lots of data sets, right? Like the Oracle instances of companies that I've been involved in, sometimes we have hundreds, right, of database instances, thousands of data attributes. Like, it's crazy. We have to get a little more rational about this. We really want to throw out the one schema to rule them all, right? This idea that you can create the uber enterprise data schema that's going to map all your stuff, like it just doesn't work. I fundamentally have a problem with this term master data management. Like, you know, it just doesn't work, right? And it's, you know, very difficult, and even if you try to do it, it's been around for 10 plus years, and it still hasn't really worked very well. Modern viz is really important. Like, no longer is it a big natural. I really believe that the, you know, people that are still using Cognos and BO, like these things are, you know, they're nice little repertoire, but like you can do an awful lot really, really quickly with D3 and Tableau and Spotfire if you need something really fancy. So just embrace it. It's really, they're really easy to use, and they're relatively affordable. The cloud is inevitable. Along with the cloud, for me, comes DevOps, and you have to get really good at that. You have to embrace JSON. I think that's absolutely essential. And that if you get into these, so I have a real problem with many of the people in the NoSQL community and a lot of these, you know, folks in the open source community. They like to sort of, you know, talk about, you know, sort of liberating the enterprise. I really think that the benefit of these open source systems, these distributed systems, like the H word, are, you know, is that you sort of start to get yourself less dependent on these big enterprise systems providers. And again, I bought a lot of Oracle in my day. I bought a lot of EMC in my day, right? But it's time that we kind of draw a line in the sand and say, no. Like, if we can manage our data more effectively with an open source platform on a truly distributed set of infrastructure, I don't know if anybody remembers, there was a distributed database written in the early 1990s called Condor. Great system. When you look under the covers of Condor, you look under the covers of HDFS, you see a lot of the same fundamental design patterns, right? These are ideas that have been around for a long time. It's time for us to put them into practice. And in the way to justify the cost of those systems and the cost to implement them is like, well, if you save 10% of the money that you spend on Oracle or EMC or both, you're going to find more than enough money to pay for the implementation of those new systems. So, as always, I've tried to be a little bit, you know, sort of controversial, and maybe said some things that made some people unhappy. It's only interesting when people stand up and do that. But I'd love to take some questions now. Thank you. With JSON is to pick up Mongo or Couch and start actually just, you know, writing systems, writing code, playing around with it. You know, it's the kind of the classic, you know, examples that he bundled with, you know, SQL Server and Postgres that, you know, sort of taught lots of people how to write SQL, and it's the same, exactly the same kind of thing. And also, for development, I mean, again, one of the real advantages of JSON is, like, for developers and anybody that's been doing, you know, modern development, you know, in the last 10 or 15 years, it's going to feel like falling off the wall, right? It just makes it so much easier. It's really cool. Yo. This is pretty close to mine.
Justin Langus do a quick bio. Andy, I looked at your white paper, I think, as you were developing Tamr, and I was fascinated with the human interaction with your system, data wrangler, and some aspects of what you're thinking there. Yeah. I didn't see that.
So the history behind Data Wrangler that Hare and Joey Hellerstein and these guys on the West Coast wrote, and Tamr is pretty close. So Data Tamr is to Data Wrangler and Trifacta, Joey and Jeff's company, as source code control systems are to you know, code to VI and all the system you write to actually write the code. Data Wrangler is an interface that you use to combine a small number of sources together and like do this sort of idiosyncratic thing more efficiently. At Tamr, we're much more about the actual control of all these data sources and the mapping of all these data sources in an integrated way. The kind of things that we like to reference are A lot of us have done data management for years. Like you're going to go through this process of setting up and doing, phone number transformations, right? Dashes to parens or parens to dashes back and forth, social security numbers, and all these things. Like you shouldn't have to do any of that stuff, right? Like your data should kind of come prepared. And there have been studies that have gone on in data systems or in data science where they estimate between 80 and 90% of data scientists' time is actually spent preparing the data to be analyzed and used. And we really want to take that down to like as close to zero as humanly possible. The data should come prepared in the form where it can be used and analyzed, regardless of where it came from, regardless of how diverse the sources are that you're using.
Who do you see as a competitor for Tamr?
The biggest competitor for Tamr is probably the dogma of deterministic data mapping and matching, right? The belief that the first thing you do, we run into this all the time with our customers, where well, the first thing you do is map attributes. I'm like, no, actually, the first thing that you do is, point something like Tamr at your data, and it kind of tells you, well, here's how I think the data's mapped, and here's how I think the records overlap. And that is probably the biggest, challenge that we have. Many of the ETL vendors, especially the pure plays, Informatica, we've got a great relationship with Informatica. They really believe that in order to address the long tail of data sources, that you have to do something very similar to what Tamr has. Same thing is true at Tahoe and Talent and all these great ETL vendors. It's just kind of not in their wheelhouse to take this bottom-up approach. So almost antithetical to them. And so all the conversations we've had with the ETL vendors has been very complimentary. So it's this missing piece. And when Mike and I first started Tamr, that was the principle. Like neither Mike and I really needed to start another company. We don't need the money. The reason we did this is we felt that there was this sort of gap. There was this glaring hole. And we wanted to start a company that built a product that people needed. Yeah.
Take one more question, please.
Yeah.
Yep.
I have a question about the algorithm that you use for the data matching. So
Uh-oh.
we actually are working on.
Did you see my title, CEO? I'm CTO. That's okay. Go ahead. I'm supposed to be an engineer.
On a day-to-day basis, we connect all of the sources of information and
Yeah.
do that thing, right, to optimize the process itself, and we know how to match it, guess which fields are, how to match to each other. And there are, of course, probably some percent of the relations that we actually do it, but what to do is use using. So the process, people may label things, but actually what's difference, how does your system operate with this
Well, so first and foremost, we're building a very horizontal system that can map any data together, and it's remarkable actually how horizontal this problem is. The approach that we've taken is that we've really tried to not build a system that's optimized around how the data is going to be used, but it's rather completely bottom up. And one of the things that we do in Tamr is we try and do as much as we can with modern machine learning. Most of the algorithms we use are really, really pedestrian, but they scale really, really well. And once we sort of run these algorithms, what we do is we come up with confidence levels, confidence intervals for all of the mapping between attributes and all the matching between records. And so we never take anything as binary or rote. And so then when we engage with people and we start asking them questions, those questions are designed to tune the confidence levels and increase the confidence levels as much as possible. And so we sort of use this term, machine-driven, human-guided. And we really believe it's that interplay between the two that's absolutely essential. So it's neither sort of assuming that the algorithms can do it all, nor assuming that the humans are going to do all the top-down matching themselves, mapping and matching themselves. And it's that intricate combination of the machine and the human we think that really differentiate the system.